All right, so before we talked about the quotient rule, we could find derivatives of quotients or two things divided, but we'd have to rewrite them in a way so that they are not a quotient anymore. For example, this one here, you could divide by x squared, and you would have 2x minus 3 plus 2x to the negative 2. And then you guys could have taken the derivative, right? That's how you would have found the derivative of that function that looks like this before today, okay? But today we're going to talk about a quotient rule that you can use to find the derivatives of the quotients. Not every quotient will be able to be rewritten, so you will have to use the quotient rule, right? If it is cosine x over e to the x, you can't rewrite that. So you're going to have to use the quotient rule, okay? So what does the quotient rule say? It says if you have the derivative of a quotient, f of x divided by g of x, first you're going to do something kind of similar to the product rule, but it's going to matter what order you do it in because we're going to subtract now instead of add. So we're going to take the bottom function first. So we're just going to keep the bottom function as is, g of x, multiply by the derivative of the top function. So kind of like the product rule, right? Original function times the derivative of the other one. But now we're subtracting times top function, derivative of the bottom. So it does matter that you do the derivative of the top with the original function on the bottom first, okay? Because we're subtracting, so it does matter. And that will all be divided by the original function on the bottom squared. That is how you can find a derivative of a quotient. That is the quotient rule. There's kind of a little like sing-songy phrase that I like to use to help me remember. And it goes as follows. Low, d high, low d high. So low function, d high, derivative of high, right? Low d high, low derivative of high, minus high d low. All over the square of what's below. Low d high minus high d low, all over the square of what's below. So low function times the derivative of the top function, d high, minus high, top function, derivative of the low, d low, all over the square of what's below. So that can kind of just help you remember which one comes first. So let's go ahead and use this quotient rule to find the derivative of that function that we talked about earlier. Yes, you could find it without the quotient rule, but we're going to just use that to help us understand it. So if I want to find f prime of x, I'm going to start with the low bottom function. D high, derivative of the top function. So 6x squared minus 6x, just derivative of the top function. That's low d high minus high, top function, d low, derivative of the bottom function, 2x, all over the square of what's below. So x squared squared. Now let's simplify and multiply this out. So we'll get 6x to the fourth minus 6x cubed minus 4x to the fourth plus 6x cubed minus 4x all over x to the fourth. Combine some like terms. And we've got 2x to the fourth minus 4x all over x to the fourth. Is there anything else I can do? Is that done? Can that simplify anymore? We got a common factor, right? In the top and the bottom. The top terms all have a common x. So pull that x out. 2x to the third minus 4. So this becomes 2x cubed minus 4 over x cubed. That is your final answer. Again, don't box your answers on the AP test, but just to kind of draw your attention to it as a teacher, that's why I'm boxing it. Okay, so for this next example, it says to write the equation of a tangent line. Sorry, any questions on that one? How we use the quotient rule? I think it's pretty black and white, but any questions? All right, let us find the equation of the tangent line. What two things do we need to write an equation of a line? Point and slope. The point will be g at -2. That's pretty easy to find, right? Just plug g into -2 into g. So we'll have -4 minus 1 over -2 plus 3, which is -5 over 1, or -5. So there's your point. I also need a slope. How am I going to find the slope of the tangent line? What do I need to find the slope of the tangent line? The derivative at -2. So let's start with the derivative and then we'll plug in -2. Okay, so let's find g prime of x first and then we'll plug in -2. So we'll start with low, x plus 3. And this would be a perfect example of something that you would not be able to rewrite, right? Like there is no way to find the derivative of this without the quotient rule. So low d high minus high. Derivative of the bottom is 1 all over low squared. You could go ahead and plug in -2 at this point, but let's simplify it just to practice that simplifying. So go ahead and simplify it down on your own. Should be 7 over x plus 3 squared when you simplify it down. So that's our derivative. And then we want the derivative at -2. So now we can plug in -2. And we'll get 7 for the slope. So now we can write the equation of our tangent line will be y plus 5 equals 7 times x plus 2. Any questions about that one? All right, I want you to try this next one on your own. It says show that the derivative is -3 over x minus 1 squared. Don't worry about that part. Just find the derivative first. And if you don't know how to get it to look like that answer, I will help you with that. So start by just finding the derivative. If you don't get -3 over x minus 1 squared, I'll help you with that part. But start just by using your quotient rule to take the derivative. So up here at the top at the board, I have the first step, right? Low, d high, minus high, d low, all over the square of what's below. So that would be the first step. Then you can go ahead and distribute. When you distribute, you should have 2x cubed plus 3x squared minus 2x minus 3. Then from the second one, you would have minus 2x cubed minus 6x squared minus 4x. And this is all over x squared minus 1 squared. Okay, then if we simplify that, we should end up with, combine our like terms, 2x cubed minus 2x cubed will be 0. 3x squared minus 6x squared will be negative 3x squared. Negative 2x minus 4x will be negative 6x. And then negative 3. And from here, you might be asking ourselves, how in the world are we supposed to get to this? This is what they say the derivative is. Do we have any questions first about how we got here? Any questions about how we got here? Okay, so then how are you going to get to this? Well, we can keep simplifying. There's some more simplifying that I can do. So first, what common factor can I pull out at the top? A negative 3. Let's pull out a negative 3. Then I'll have x squared plus 2x plus 1. And the bottom is x squared minus 1 squared. But what does x squared minus 1 factor into? What is x squared minus 1? Just that. What does that factor into? X plus 1, x minus 1, right? And that's squared. So there's x plus 1, x minus 1 twice, right? So this is x plus 1, x minus 1, x plus 1, x minus 1. All on the bottom. Does that make sense? Because this is x plus 1, x minus 1. Right? That factors in x plus 1, x minus 1, and then that's squared, so there's double that down there. And then what can you do with the top? Factor that. Yeah, x plus 1, or x plus 1 squared.
And the bottom's x plus 1 squared is 12 times x minus 1 squared.
Yep, exactly. So boom, 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 boom. Oops, I have an extra plus down here. And then we end up with negative 3 over x minus 1 squared. Would you agree that that was a lot of work for one simple derivative? Would you like a faster way to do this one than all of that? Yeah? All right. Whether you're doing product or quotient rule, okay, if you can simplify before taking the derivative, okay? It will make your life a lot easier. So same derivative, okay, but I'm going to show you a faster way. So let's simplify it before we take the derivative. How would I be able to simplify this? Yeah, factor it first. Let's factor it first. So we'll have x plus 1, x plus 2 in the top. X plus 1, x minus 1 in the bottom. So really, this is just x plus 2 over x minus 1. Did I take a derivative yet, though? No, I just simplified. So now let's use the quotient rule to take this derivative. So low, x minus 1, d high, derivative of the top will just be 1, right? Derivative of x plus 2 will just be 1. Minus high, derivative of the bottom, which is just 1, all over the square of what's below. Simplify out the top, and we just get negative 3 over x minus 1 squared. Much faster? Yes. Much faster than that big, long simplifying that we did before. Okay, So whether you're using any derivatives at all, if you can simplify before you take your derivative, simplify and then take your derivative, you will make your life a lot easier. So that is your lesson to be learned. Simplify before deriving. Any questions on that one? Okay, we already know the derivative of two trigonometric functions. What's the derivative of sine? Cosine. What's the derivative of cosine? Here's the other four, okay? Other most common trigonometric functions, right? Tangent, right, is sine over cosine. Cotangent, secant, and cosecant, okay? So we are going to find the derivative right now. Why did I, right now, say today, when we're talking about the quotient rule, say we're going to find the derivative of tangent theta?
Sine over cosine.
Because tangent is sine over cosine, which is a quotient, right? So now we can take the derivative of this, right? Because we know that tangent is sine over cosine. So write down tangent as sine over cosine. And let's use our quotient rule to find the derivative. So we'll start with low. That's cosine theta. What's the derivative of sine? Cosine. So times cosine theta. Minus high. Sine theta. What's the derivative of cosine? Negative sine. All over the square of what's below, cosine squared theta. Then this becomes cosine squared theta plus sine squared theta all over cosine squared theta. What's cosine squared theta plus sine squared theta? 1. So this is 1 over cosine squared theta. Or what's 1 over cosine the same thing as? Secant. So this is secant squared theta. So the derivative of tangent is secant squared. This is one you're going to want to memorize. You're not going to want to use the quotient rule on this all the time. It will take you way too long. You want to memorize the derivative of tangent is secant squared theta, just like you memorized sine and cosine. Okay? Let's do... how about you try this one? Cotangent, why would we do this one with the quotient rule? What is cotangent? Yeah, cosine over sine. So go ahead and do that on your own. See if you can figure out what it simplifies to. Take the derivative using the quotient rule and see if you can figure out what it simplifies to. All right, so when you do the quotient rule on this one, you should get low is sine, derivative of cosine is negative sine, low d high, minus high. D low, derivative of sine is cosine. All over low squared. So then you'll get negative sine squared theta minus cosine squared theta over sine squared theta. Did we all get here to this part at least? Yeah, with the great signs. So now, this isn't 1, but it's what? -1, because if you factor out a negative out of both of those, don't we have sine squared plus cosine squared? If we pull out a negative, right? So that's going to be -1 over sine squared. And what is 1 over sine? The same as cosecant. So this is negative cosecant squared. And you're going to want to memorize this one. You are not going to want to do the quotient rule every time you have to find this derivative. You're going to want to think the derivative of cotangent is negative cosecant squared, okay? You could also, we're not going to do the next two. You could. Why could you do this with the quotient rule? What is secant the same thing as? 1 over cosine. So you could do it with the quotient rule if you want, but I'm just going to tell you what it is. If you want to try it on your own time and simplify, you can. It is tangent theta times secant theta. And why could you use the quotient rule on cosecant? What is cosecant the same as? 1 over sine. So you could use the quotient rule, but I'm just going to tell you the derivative if you want to try it on your own and see, is negative cotangent theta cosecant theta. So these are 4 derivatives you're going to want to memorize, okay? You're not going to want to find these every single time, but let me point out some tricks that will help you, okay? 1, they go together. What's the derivative of tangent? Secant squared. What's the derivative of secant? Tangent secant, right? So tangent and secant always go together, right? And then this one is similar. The derivative of cotangent is not secant squared, but cosecant squared is just negative, right? And then the derivative of cosecant is negative cotangent cosecant, right? So do you see the pattern? Like the cosecant and the cotangent go together, and they're negative, and then the secant and the tangent go together. We both have secant squared. We have squareds, and then just the 2 functions multiplied together. So they're kind of easy to memorize. Any questions? All right. I'm going to give you the answer to this next one if you want to try it on your own. And then I want you to do the second one. So if you want to try this one on your own, you're welcome to. You should get when you're done, f prime of x is equal to x squared plus 4x minus 4 over x plus 1 squared, or x plus 2 squared. But I want you to do this one. Try this one on your own. So we do have to use the quotient rule because it's a quotient. So we'll start with low, theta squared, times the derivative of the top. What's the derivative of sine? Cosine theta, minus high, sine theta. What's the derivative of theta squared? 2 theta. So the first power is just 2 theta. All over theta squared squared, which will be theta to the 4th power. How could I simplify this, though? This could be simplified a little bit. Yeah, do we have a common factor in the top? Yeah, we have. Now, question, can I factor out this theta right here? No. Inside the sine and the cosine, am I allowed to pull that out? No, but this is a theta squared and this is times the 2 theta, right? So I do have a common theta I can pull out. So I'll be left with theta cosine theta minus 2 sine theta all over theta to the 4th. But then I will cancel that out and it'll be theta to the 3rd when I cancel that out with the top one. All right, let's do some more abstract problems where we're not given explicit functions, so we have to use a table. First, estimate the value of g prime 2.5. This has nothing to do with the quotient rule. This is a review problem. So estimate the value of this derivative. Do it on your own. Should I pick a random number between -1 and -3? Should I pick a number halfway through test? Oh, not. That's not g prime. Between -1 and 6 to find g of 2.5? No. How do I estimate a derivative? What do I need to find? Derivative is what kind of rate of change? Instantaneous. How do you approximate an instantaneous rate of change? An average rate of change. What is an average rate of change? The slope between what? 2 points. What 2 points do you want to pick here if you're trying to approximate it at 2.5? 2 and 3. Good. So you want to find g of 3 minus g of 2 all over 3 minus 2. Anytime they want us to estimate a derivative, we want to pick 2 points around that value and find the average rate of change to approximate the instantaneous rate of change. So it'll be -3 minus -1 over 1. Oops. Which will be -3 plus 1, which is -2. So g prime of 2.5 is approximately -2. All right, I want you to try this one on your own. Here, you don't know what g and f are, but that's okay. You still should use the quotient rule because it's a quotient of 2 functions. And then use your table to find the values. But first, write down what p prime of x is. Write down what that function is, then plug in 4. So try this one on your own. This table feel like this? Okay. Compare what you got with your table. torture. All right, so when you do the derivative using the quotient rule, you're going to have low d high minus high d low all over the square of what's below. And then you should end up with 1 times negative 2 minus 7 times 8 all over 1 squared, which is negative 58. So you should have gotten negative 58. What is this number graphically? Since it's G prime or P prime at 4, what is this number on a graph? Slope of the tangent line at 4, right? This is the slope of the tangent line at 4. All right, now we got a doozy in front of us next. Do you think you should use the quotient rule on this? At some point, yes. Why? Because you see f of x divided by g of x, right? But I cannot start with the quotient rule here. Because what's the first thing that's happening here? 2x squared times f of x divided by g of x. So what do I have to start using for this problem? The product rule. I got to start this problem with the product rule. Because first and foremost, it's a product. So first function, 2x squared. Then I'll do the derivative of f of x divided by g of x, right? First function times the derivative of this function. Now when I go to do the derivative of this function, what am I going to have to use? The quotient rule. So let's do that right now. So low, d high, minus high, d low, all over the square of what's below. That's all multiplied by 2x squared, right? Because that was just the first function times the derivative of the second function. Is that it? Is that the derivative? Did I finish the product rule? No, I just did the first function times the derivative of the second function, right? What else do I have to do for the product rule? Plus the second function times the derivative of the first function, right? So plus the second function times the derivative of the first function, which will be 4x. Sorry, that said q of x. It should say q prime of x. Now we can plug in 2. So we'll have 2 times 4. Go ahead and plug in the rest of the values on your own. And you should end up with negative 72. So here you should have 2 times 4. Inside here you should have negative 9 plus 2 over negative 1 squared, the quotient rule part. Over here you should have a negative 2 times 8. So you'll have 8 times negative 7. All of this should be negative 7. If you didn't get negative 7 in there, go check those values. So then minus 16. which will be negative 72. Any questions on that one? All right, I want you to finish it off by doing the last one on your own. You're going to find the slope of the tangent line, you'll need the derivative. To find the point, you'll need v at 3. No one's playing right now. Why do you yourself away? At the time, we had this. Now we have 3 minutes left. I still need something. But not have to get more minus. Here's your answer up here, what you should have gotten.
I don't know. I'd like to say that